Hello, let's continue our advanced Sudoku series with Gameun Deut by Shye. This is puzzle number 4 of the 5th chapter of the Sudokult Gospel document. It is actually the last puzzle of the 5th chapter. It's a short chapter, and we have one more chapter to go until we're finally done with this document. I hope you're all enjoying it. We're really getting into the nitty-gritty puzzles here with using these crazy techniques. So, hopefully you're along for the ride in some way. Maybe you're enjoying them. Maybe you're finding alternative ways to solve them. And then turning to me to see what the intention was. And that is what I'm trying to provide. But anyway, there is as always, I know what technique I'm looking for. And in this case, I suspect I know what that means. We'll see. We'll see how I do. Maybe like last puzzle, I may end up having to investigate and coming back, but I'm hopeful on this one that I may be able to figure it out. But anyway, there's a link in the description both to the document and this puzzle if you'd like to try it yourself. And I'm going to get started right now. Right, I saw while I was talking that there's these 2s looking in, so we can place this 2 here. And I'm going to fill out all of these cells. We have 1, 2, 3. We need 4, 5, 6, and 9. Okay, I'm going to fill these all out as well because, I mean, look at this. Like, if this isn't intentional, I don't know what is with these open gaps here. So I'm going to fill all of this out. So I need 2, 3, 4, 6, and 9. Okay. Boop, 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 boop. Let's fill this out too. It's 4, 5, 6, 9. Let's fill this out. We've got 4, 5, 7, 8, 9. Oh, shoot. 4, 8, 9 there. 5, 8 there. And then let's fill this out. I need a 2, 5, 6, 7, 9. Clean that up a bit. All right. I think I'm going to look for the thing right away and see if I see it. And if I don't, I'll have to do more Sudoku. But we're paying attention to these rows that I filled out here. Is what we're doing. Maybe I should just double check that there isn't any more. Like there was this really obvious hidden single here. I could double check that there's not more of like that. We've got 6s in one of these 2. We got 4 digits left here. 4, 5, 6, 9. Okay, so not quite. What am I looking at here? All right, let's take a look. Here I'm not seeing any. So what I'm looking for here are ALSs. Similar to our last puzzle, I'm looking for ALSs that have a digit, 2 digits that appear only once each. So like this felt like a candidate to me, but unfortunately 2, 3, 4, 6, 9 is 2, 3, 4, 6, 9 is 5 digits into 3 cells, so that's not an appropriate one. We do have this 4, 5, 6, 9 here. And the 4 appears once, and the 9 appears once, and the 6 appears once. 4, 5, 6, 9. The 5 is the only one that actually repeats. I've got 4, 5, 7, 9 here in purple. That's an ALS. Obviously, it's always any time you take all the digits, all the cells left in a house, and you remove one of them, that's an ALS. But what I'm noticing is we've got the 9 appearing once. Everything else can repeat. I'm not sure if that one's helpful at the moment. I can't make the 4 appear only once. How about down here? 2, 7, 9. I'm not seeing anything here. So maybe I misread the intention here. Is there anything up here? Or maybe there's more Sudoku I need to do first. It's quite possible. I didn't do any. Barely any. There's a 3 in one of these 2. Let's see if I can find anything that does not something non-trivial. Pair, triple, or pointing, claiming. Anything interesting here? Not really seeing anything obvious at the moment. Ones down here. It's not claiming ones. It'll just be helpful in the solve at the end, probably. All right, so what can I do here? Okay, so in this ALS, and again, we know it's an ALS just from the fact that it's 4 out of the 5 cells. The 2 is limited to 2 spots. Is that what I want to look for? It doesn't mean we have to have a 2 though. Okay, but we have it here too. Okay, I think this might be what we're looking for. Let me think about it, because I think I have to prove this to myself. This might not be it. Let me check. Yeah, Ooh, this looks so juicy though. These lining up. What I'm noticing here is almost like an ALS X-wing, right? It's not really, because 2 can be missing from both of these because they're ALSs. We could put a 2 here and a 2 here, unless we can prove that we can't. But I don't see a reason we can't. No. But you can see that 2 is limited to the same columns between these. That feels intentional. If 2 was missing, we would be locked sets. I'm not sure that's enough. What if it was actually vertical here? What if it was these? Let's use purple and orange again. So what is this even an ALS? 2, 3, 4, 5, 7. 2, 3, 4, 5, 7. That's an ALS. And this is 2, 3, 5, 6, 7. 2, 3, 5, 6, 7. That's also an ALS. In this ALS, 3 is only in this cell. And 3 is only in this cell. That, I think, is key here. So what am I talking about here? Well, orange is an ALS, purple is an ALS. If you think about 3, how 3 works in these, only one of these 2 is a 3. Now think about how 2 works in these. Okay, let's think about this again. My point at the moment, and it's not a full thought, my point at the moment is that both orange and purple can't both have a 3 in them, which means one of them is a quadruple. One of them is a lock set that omits a 3. One of them is. Do we want to think about what happens if both of them are missing a 3? Because maybe that's the issue. Maybe the issue is they can't both be locked sets. They would both need a 2 in that case, and we'd make an X-wing on 2s. Which would eliminate 2s from here and here. So in one case, a 3 exists, and we eliminate a 3 from all of these cells. In the other case, a 2 exists in one of these cells, in which case this one's not a 2. Those don't have an overlap, but I'm thinking about it. Something else. I feel like this is key. I feel like this is intentional. And I just need to figure out what it was called a doubly linked ALS XZ rule or something along those lines. And I'm wondering what the doubly linked part is referring to, which I couldn't find. So we're figuring it out. I don't know if this is of note, but this is an ALS as well. We need a 4 or a 6 in here. So let me just plunk this out. We know what happens if one of these is a 3. The other one becomes a lock set. But what happens if both of them aren't 3? We end up eliminating this 2, and we end up eliminating this 2 because we have an X-wing on 2s now. Because these are lock sets. These are both quads. This is a 2, 5, 6, 7 quad, and this is a 2, 4, 5, 7 quad, and it eliminates 2s from the rest of the columns as a result, which gives us an X-wing on 2s. What about any other digit? We also get an X-wing on 7s, so all these 7s get eliminated. Okay, what else? 2 5s aren't as interesting. And then we have to have a 4 somewhere in here, but we have to have a 6 somewhere in here. 2, 5, 6, 7, the 5, 2, 5, 6, 7. I'm trying to see if this case breaks. Because if it breaks, then we must have a 3 in one of these two, and then we can eliminate that 3. If it doesn't break, maybe there's a similar consequence to eliminating this 3, which doesn't feel like it's happening. Okay, I'm going to undo that because I don't think that was fruitful. So we can't just say without the 3s, things break. A lot of things happen, but they don't necessarily break. Maybe I should pencil the rest of these columns and just see what they can be. I'm gonna do it the cheaty way here. Not 2, 3, 4, not 8, 9, not 4, 5, 7, 9, not 6, 8, 9, not 3, 4, 6, 9, not 1, 2, 6, 9, not 1, 4, 9. Okay. This 1, 5, 6, 9, it might be interesting. Sorry, 1, 5, 6, 7. I don't know why I said 9. Because without the 3, this becomes a 2, 5, 6, 7. So this becomes a 1 in that case. And then here without the 3, we get a 2, 4, 5, 7. This becomes a 3, 8. Not as exciting. Because the other thing I'm considering is that one of these is missing the 3. So one of these is actually one of those quads. I really feel like I've found the right cells involved, but maybe there's more cells involved that I haven't understood to really drive this home. It feels so close, but I'm not getting it. There's like one little light switch moment that's missing here. Is the fact that these are also ALSs. So let's think about that. Maybe it's like a square of ALSs. So let's make this blue and let's make this yellow for reasons. Okay. So in this case, 2 is in one of these two and 2 is in one of these two, right? For these ALSs. We know that at least one of these 2s is true. Because if we omitted all of these 2s, then both orange and purple would need to have a 3, and they can't both have a 3. Because they share a row. So one of these is a 2. What does that do for us? Feels important. I think it's key. Like, these 2s are very, very obviously placed here. Now that I'm thinking about it, like, it's key that the 2s are limited, both in the yellow and blue and both in the orange and purple. All of these ALSs have these 2s limited. And if the 2s were omitted entirely, then they'd all be lock sets. And that's no good, right? If we omit the 2s entirely, that's no good because these both need to be 3. I might have mentioned that before, but I'm thinking out loud here. And sometimes that requires repeating stuff. So one of these is a 2, which I did mention. At least one of these is a 2. We could have up to 2 of them be 2s. Do we want to think about what happens in all of those cases? I'm not getting it. I feel like I'm like one step away from understanding this, but I'm not going to waste any more time on it. Or I'm not going to waste any more of your time on it. So I'll investigate this and I'll get back to you. All right, I figured it out, and it was after I penciled the whole grid because I had not penciled these cells. I was looking in the wrong place, and it's kind of interesting how similar these ended up. So unfortunate. But yeah, I hadn't noticed kind of this pattern of givens here, giving us these kind of holes. This is a lot more straightforward too. I also found this hidden 3/8 pair while I was doing it, but anyway. So we're fully marked, and I've got these. So we have an ALS in this row and ALS in this row, the green. I'll change the greens to purple and orange here. So in this ALS, it's 3, 4, 5, 7. The 3 only appears in one place, and the 7 only appears in one place. So we definitely have a 3 or a 7 here. We can't be missing both the 3 and the 7, or it would be only 4s and 5s. Very similarly here, we've got 3, 5, 6, 7, and the 3 only appears in one place, and the 7 only appears in one place. There's something special about this. The one place the 3 appears, and the one place the 7 appears is the same as the purple. And so the conclusion here is these can't both be 3, these can't both be 7. So one of these 3s is missing, and one of these 7s is missing. But the other one is there. Right? So if one of these 3s is missing, then one of these 7s is there. And if one of these 7s is missing, then one of these 3s is there. So the first conclusion we can make is that it's kind of like an X-wing, right? But it's 3s in this column and 7s in this column. So I can eliminate 3s from the rest of this column. And I can eliminate 7s from the rest of this column. But in addition to that, we know that there's going to be a 4 and a 5 in this row because we know either the 3 or the 7 is missing. So there's going to be a 4 or a 5. So we can eliminate 4 and 5 from this row. And we also know there's going to be a 5 and a 6 in this row because either the 3 or the 7 is going to be missing. And so the 5 and the 6 must be present. And so from here, it should solve pretty nicely. You can get rid of the colors here. First thing is in this box, there's only one place for 7 now. Eliminates those 7s. That gives us this 5, gives us the 6. These are not 5 6s. That's not a 6. It's not a 5. All right, that's not 7. Let's clean this up a bit. We get a 4 9 pair here. What else we get? We had this 3 8, 4 5 9. All right. I think I just have to scan this, and it's fully marked, so it's a little hard. But this 7's gone. Right. Oh no, I was going to say 9 in this column, but no. 2 1 2. So let's focus on the eliminated digits here. It's not those. I'm going to rehighlight this just in green so I can remind myself what rows and columns got eliminations. 7 8 1 1 7 8. So this is a 1 7 8 triple. So these can't be 7. This can't be 8. This can't be 8. This can't be 1. Did I get anything else like that? I think I'm just missing something a little bit simple, but this 1 7 pair, 4 9 pair. Sorry, I'm trying to find what to do here. Thought that would do it. I still think it did. I've got 6 in one of these two, a box. Okay, I'll figure out what to do and I'll come back. Okay, I found what I was missing, and it is these 6s up here pointing. So these 6s point, these are not 6s, and then now in this column, 6s are claiming in this box. So these are not 6s. And now in this row, this ends up a 6, which places that 6. And these aren't 6s. And now the effect on this row is now 9 is in one of these two. This was so hard to find. All right, so 9s are not there. And so now in this column, 9 is here. So these are not 9s. And then now 9 in this column is here. That gives us this 5 and this 4, and the 9 in this box is also here. Yeah, okay. So these aren't 4, that's not 5, so that's a 9. That places that 9. We get our 4 here, we get our 9 and our 4 here. So let's get rid of the 4, 9 here, get rid of the 6 corner marks. Let's clean this up. This ends up a 3. Remember, that makes that a 7, right? But we can see, watch that happen. That's 5, that's 6, that's 7. That's not a 7. Don't think I need any of these anymore. This did end up a 4, 5 pair here. That's an 8, 2, 9, 7, and 3. That's our 5 and our 2. We get our 1 and our 8 and our 5 and our 6. This is 4 and 7, 1 and 3, 6 and 5, 1, 7, 1, 4, 2, 8, 7, 6, 5, 3, 8, 4, 3, 4, 5, 1, 2, 7, 3, 8. And we're done. All right. Sorry for the hiccups there. These are tough puzzles, and then once I'm fully marked, it's hard to it's hard to find stuff like pointing. And then like it only happens because of the eliminations we made. So yeah, it's a sticky situation there. But yeah, I hope this was helpful. I hope this was enjoyable. I'm sorry about finding the completely wrong thing there. That really felt super telegraphed to me, the ones that were around this ring here. But I couldn't figure out what to do with them, and it's because I was supposed to use these cells. And as you can see from these cells, this ended up 3, this ended up 7. The only other option was this was 3 and this was 7, right? And this did have a 4, 5 in it. This did have a 5, 6 in it. So that part was all correct once I found it. And then I still couldn't finish the puzzle because we had pointing 6s, claiming 6s, placing that 6, claiming these 9s, and then claiming those 9s placed this 9 and this 9 and this 9. But anyway, yeah, hope you enjoyed this. And if you did, then why not leave a like, subscribe, and a kind comment below.